Now we know how array is working. What is an array? How we are declaring an array? How we are accessing various elements of an array. Fine. We also know the thing pointer to an array. Fine. We can also use a pointer to an array, and with that, the help of that pointer, we can also access the elements of individual array. We know all this. Right? Now, in array, basically we need to cover three things. First is basics of array that we have covered. Second, pointer to an array that we have covered. At least pointer to one-dimensional array we have covered. Right? Then the third thing is how you pass an array to a function. Right? Array is also a basically a data type, a derived type of data type. Fine. As we are passing various variables of basic data type, we learn to pass to a function. Fine. We understand function. In that function, we can pass various types of variables like integer variable, character variable, float variable, unsigned int variable, so on and so forth. Right. Same way, is it possible to pass an array to a function? Yes. It is. It is. There are various ways we can pass an array to a function. Precisely today we will be doing that next topic. That how to pass an array to a function. Right? So precisely there are three ways. Passing array to a function using call by value method. Passing array to a function using call by reference. Passing an entire array to a function as an argument. This we can do in two ways that we will discuss how. One way is the same thing, using a pointer to an array. Fine? Using a pointer to an array, we can access the complete array and pass it to another function. Right? There is another way, we'll discuss that too. Right? So let's first discuss these two are very basic ones, call by value method and call by reference method. Let's discuss the first method, call by value method of passing an array to a function. Fine. Now let's look here in this very simple basic program. We have two functions. One is this function that we are using, in which we are passing array elements one by one and displaying the array elements. Right? And we have another, your main function. Right? What we want is, in pass by value, we actually pass individual elements of array to another function. Fine. And again, as the call by value logic is that the value we are passing from actual parameters to formal parameters, then the formal parameters would be just a copy of value of actual parameters. That's it. Fine. So, and in call by value method of passing an array to a function, we pass individual elements of array to function, and they will be just copy of that individual elements in the other function. Right? So let's look at this program quickly. So this is our main function. Fine. And we have declared an array with name.
Your computer screen is not visible.
Sorry? Screen is not visible. Oh, sorry, dear. Let me just. Thank you for letting me know that. However, it's 2 minutes late. I'm going back to this. So we can pass three ways. There's three methods. Fine. In the third method, we have two ways, using a pointer and some other way. We'll discuss that. Fine. So let's discuss the first one, call by value, and whatever the logic for call by value is, whatever that the value of actual parameters is just a copy of value of formal parameters. Simple. Fine. So let's discuss this program. Here we have two functions. The first one is this function, right? And the second one is our main function, right? Okay. What we are doing, will be doing is, in the disk function, we'll be passing individual element of the array. If we have an array of say 10 elements, we will first pass the first element, then second element, then third element, so on and so forth, right? And in the disk function, that value is just like copy of original value. Whatever changes you will make there, that they won't reflect into the actual array. Fine. That is the concept of call by value. So let's look here how we are doing so. That's very simple. Go to the main function. Here we are creating an character array this time. Fine, we are creating a character array. So once we are creating a character array, so individual elements of that array would be a character value. Fine, fine. Now, individual elements are character value, as well as you will see we are initializing them at the same point of time. We are here creating an array of size 10. So what would happen? It is a character array of 10 characters, and one character takes space of 1 byte. So 10 characters will take space of 10 bytes. So again, the space created for array 8RR is 10 bytes. Fine. In case of that 10 bytes are block of 1 byte each. That 10 bytes is a block of 10 bytes. Is a consecutive storage of 10 bytes. Fine. And individual 1 byte you will be storing one array element, because you are storing a character which will be taking only 1 byte of space. Fine. So let's do that. Okay. 10 bytes. Fine. And the first element again will be accessing as ARR index value 0. Second will be ARR index value 1. So on and so forth. And the last element would be with index value 9. We all understand that? Right? And array initialized. That is how you initialize with a character. You always put a character in single quotes. You must have read that by now. And what actually will happen is, if this space A is stored, and B is stored, C, D, E, F, G, H, I, J. Simple? Simple? Fine. If this is the base address 200, first address, this will be 201, 202, 203, so on and so forth. It will be up to 209. Fine. 10 bytes of continuous memory. Correct? Now again you created another character array I. Okay, it should have been an integer. Please make this correction. This is semicolon, and then it would be int I, because I am using I to be index value. Int I. So 2 bytes of space for this. Let's say at address 400. Right. Loop will run, initialize to 0. And what we are doing is, okay, here we will be passing I. This is another correction. Here you will be passing is array I. Fine. Array I, if I access, like for the first loop, it will be array at index value 0. Correct? That means we are accessing this element. This element is your character A. Fine. So it will pass this character to the display function. So as we are passing this character, the control will go to this calling function. Fine. Go to stack memory allocation again. Remember, for main function, the 10 bytes of space for array was created here. 2 bytes of space for I was created here. As the control goes to display function, another slot is created. CH is the name of character parameter, formal parameter for this function, and which is initialized to this value, which is a character variable, a character A. So 1 byte of this space is created in this function. So it is same logic as by call by value. Fine. Just a copy is created. Here array exists, just a copy of that value is passed on here. Fine. Fine. And it will print that value. So on output screen, On output screen, it will just print A. Fine. Encounter the closing parenthesis, control will go back, closing parenthesis of this for loop, and what it will do, increment I. Now the value of I is 1. This I is here in the stack, this array is here in the stack, right? We all understand that, right? Okay, I is incremented, again it is less than 10, again it will pass, instead of array 0, it will pass array at index value 1, element, this element. And what is the element at this first element of this array at index 1? It is B, right? We know that, fine. So it will pass B to this character again. Oh, let's come back. When the control came back, this was freed. Again, control go back. Again, memory is created. Again, C is the correct local variable to this display function. So again, value is created and initialized to B this time, right? And it will display CH, which is storing value B. So it will display B. Again, closing parenthesis, control will come back to closing this. When the control comes back, again this space is freed. Control will come back, so on and so forth, will keep on going. On output, you will have after this execution of this complete loop, you will have A, B, C, D, E, F, G, H, I, J, up to this. First 10 characters will be printed on the output screen. Is that okay to everyone? That's very simple, right? So in call by value method of passing an array to a function, what we simply do is we will pass individual elements of array one by one. As it is call by value, so you are just passing that value of formal parameter, formal parameter will be just a copy of actual parameter. Whatever changes you will make here with the CH, they won't be reflecting back to the actual array. That's the funda of call by value, right? And for passing array, we will passing individual elements, right? Fine. That's simply call by value. Is that okay, everyone? Fine. Now, let's go to next, call by reference. Just think logically. Just think what we discussed in call by reference. It will be very same thing. But as array, we will be again passing individual element of array using call by reference. In call by reference, we were using the concept of pointer. So instead of here making your formal parameter as a variable, you will be making formal parameter a pointer variable. Again, we'll be passing individual elements. Instead of elements, now we'll be passing address of that element, and this will be just a pointer. Your formal parameter will be a pointer to that passed element, and whatever you want to print accordingly, you like using dereferencing operator to the pointer, you can print that value. Or you want to change that value, you may change that value to something else you want to do, right? If you change that value, that change will persist in the actual array. That will be the change. So just look at this one. Just look at this one. Again, we are passing individual elements at a time, but as it is called by reference, so your formal parameter is a pointer. Your actual parameter is an address, not a value. It's an address to that array element, right? As we are passing array, so again we'll be passing individual element of array one by one. But this time it is called by reference, so we'll be passing address of array element, address of array element, address of next array element, address of next array element, so on and so forth. Fine, and that in formal parameter would be a pointer. So if you want to like that individual array element will be passing one by one, we'll be just passing the address, and using that address, if you want to play just that address, you'll print that address. You want to print the value at that address, you will print the value at that address using dereferencing to the pointer. Correct? And similarly, you will be just printing the things. Do I need to explain it step by step? Anyone? Because I think we have already done lots of step-by-step execution of pointers. Do I need to do it again? If anyone wants to, then we'll execute it one by one as we did for the previous program. But can we skip this, or do you want me to do it? Please give some input so that accordingly I can decide. Yes, मैम मुझे अभी आया है कि कब आया होगा ना. So I write. It's okay, Mahesh, but okay, for now, Rajesh is saying no need to explain it step by step. Anyone wants me to do it like step by step? Okay, I'll do just one step, and rest I assume you understand the similar way. Okay, let's quickly do it then. Let me make it as quick as possible for me. Saying this is your one function, this is your second function. Right? We'll start the execution from the main function as always, right? We created an array. This time it is an integer array of 10 integer values, your basic 10 integer values. So you again created, what would be the size of ARR this time? It would be 20 bytes because you are storing 10 integers and one integer is taking 2 bytes, so 20 bytes. I'm not writing it complete, I'm just writing somewhat, okay? So, and also initializing it 1, 2, 3, 4, 5, 6, 7, sorry, 6, 7, 8, 9, and 0. That is 2 bytes of space for each element of the array, right? And the very first element is ARR 0th index, right? And this is ARR index value 1, so on and so forth, right? So as discussed, the base address is 200 for this one, and 202 for this one, and 204 for the third element, and so on and so forth, correct? Now, again, I will start with 0, and it will pass me address of ARR 0th element, right? So that means this element's base address I want to pass. Address is 200. So once you are passing this address, in this function, you are creating a pointer num, right? It is a pointer and it will store the address of array first element, that is address 200. Correct? Now, what this statement will be doing is dereferencing 200. That means whatever the value at num, that is 200, address actually, fetch the value at that address. So it will fetch a value 1 and print 1 on the output screen. Right? On the output screen, it will print 1. So after this execution, it will go back. I is incremented. Now I is 1. It will print address of array 1. So that address is 202. So in num, this time 202 is passed, right? Right? And using 202, it will dereference at address 202, so it will print 2, so on and so forth. With this way, it will just print all those elements of array 1, 2, 3, 4, 5, 6, 7, 8, 9 to 0. That's simple. That's simple. Okay. Just one thing here is, if at this point of time, let's say initially, at any point of time in this, if we do num is equal to dereference num is equal to, let's say 0. If I just make this line of code change in this whole program, then after the execution of this program, one thing, the output will be 10 zeros will be printed, right? As well as all these elements are set to 0. Sorry. All these elements are overwritten with value 0. Am I good? If I just write this line, add this line of code. Am I good with this? How it is so? Because it is call by reference. If whatever changes I make here, whatever address it is pointing to, changes will be made to that address. So accordingly, all these elements will be set to 0. Fine? You all good with this? Paka? Sure? Okay. Now let's move next. That's very interesting one. That's like kind of my favorite, and actually practically this one is used as the most, right? The third way. The third way is you want to pass an array completely, pass an entire array as an argument to a function. Fine. As we discussed, there are two ways of doing so. We'll be discussing the first way using a pointer. Fine. Now we want to pass the complete. We don't want to get into the hassle. Okay, pass first element, then pass second element. That's too cumbersome. I just want, if I have an array and I want some function to do some certain thing on that array, I just want that complete array to be passed to that. Right? Right? And that is possible. That is possible using one way is using pointers. Let's look here. Pay attention to this program now. See, this is one function. For now, just ignore it. We'll come to it later. This is your main function. We declared an array. Fine. An array of, let's say, 1, 2, 3, 4, 5, 6, 7. 7 elements. 7 integer elements. So size of this array would be 14 bytes. We all understand that? 14 continuous bytes of memory. Right? Now, as we know, just the name of the array acts as a pointer to array, storing the base address of array. Right? Right? Just look at here. Once this line of code is executed, what happens is same thing, which we are doing since long. 7 blocks. 1, 2, 3, 4, 5, 7 blocks. This is at index value 0, index value 1, index value 2, index value 3, so on and so forth at index value 6. Correct? Correct? I'm just not writing this complete big name. Actually, we understand what I'm trying to say, right? And the base address for this same, let's say 200, 202, 204, so on and so forth. Value here was 11. Value here was 22, 33, so on and so forth, 44, up to 77. Correct? Correct? Okay. Now, we have a function, my fun C function func n. That's the name of the function. Simple. So it is a function calling statement in which you are passing array name, comma 7. Fine. Array name, comma 7. Fine. This 7 is your array size actually. Right? Just to keep a track of how many elements your array has. So it is just an array size. Right? And this is array name. And we know that the name of any array acts as a pointer to that array. That means if you anywhere you are writing just the name of the array, that means you are writing the base address of that array. Right? Right? So now, if in calling function we have two parameters, two formal parameters, out of which the first formal parameter is an integer pointer. We can see this. It is an integer pointer. Correct? Right? And second one is just a simple integer variable. Right? Are we good with this? Fine? Fine. And on this calling statement, what will happen? First, this 7 will be passed to where to? So, memory is created for an integer variable named as var2, and this 7 is passed to this. Fine? Fine. Now, another pointer is created. This pointer is created with name var1, and it will store the base address of this array because you are passing the name of array, and name of array is acting as a pointer to store the base address, which is address 200. Are we good with this? Are we good with this? Now, knowing the base address of an array and knowing the size of array, we can access each and every element of array very easily. Remember the pointer arithmetics we will play now. If in this base address of array, if I just dereference at this address, I'll be referring the first element of array, which is at index 0. If I just add, I just increment this pointer, so it will point to next element. If I further increment this element, it will point to next element of array, so on so forth. So if you have base address of array and you know the size of array, then just using the pointer, you can access each and every element of array. Right? Using pointer increment or using adding a constant integer to a pointer. Either way, you can do that. Fine? Fine. So once this is passed to this, the control will go here just in one go. Just in one calling statement, you are passing complete array here by passing the base address of the array and the number of elements of the array you have passed to this function. Is that okay? Right? Now, look here. In this for loop, I think at 4 you have class, so you just complete this function quickly. Now, at this point, now you will see you have base address. What you did is, okay, this syntax is allowed only in advanced compilers. Just do it this way. Make this correction. Okay? Make this correction. Right? Now, you initialize x to be 0 and x will run up to less than var2 value, that is 7, and every time you are just incrementing it. Correct? Now, you want to print the element, this element, you want, again we want to print this individual element one by one. At that index value 0, the value is 11, index value 1, the value is 22, index value 3, index value 2, value is 33, so on and so forth. That we want to print through using this function. Is that okay? Fine. Alright. Now, how we are doing this? Using pointer increment logic we are doing this. We are doing this with this line of code. It will print value of array at in where array 0, initially x is 0, is semicolon %d, that is dereferencing var1. What is the value at var1? 200, which is an address because var1 is a pointer. Dereferencing at that value means fetch the value at address 200. So it will fetch value 11 and print this line. Fine. Next it will do is incrementing the pointer var1. Incrementing, how pointer increment works, integer pointer increment works, we know already. So after this line of code, instead of it 200, it will become 202. Correct? Correct? After this increment line. Now again, value of x will be incremented. Now initially x was 0. Initially x was 0. Now x will become 1. Fine. So again it will print where array at index 1 is semicolon dereferencing where variable 1, that means dereferencing fetch the value at address 202, at 202 value is 200, sorry 22, so it will print 22, so on so forth. The same way it will print all these elements. Simple? Is this simple? So using that, like passing the base address of an array and using a pointer to store that base address of an array, using the pointer arithmetic, anyhow, you can access all the elements of array. Am I good? Am I okay with everyone? Fine. All of you got this, how it is doing? Fine. Now write down a program. Write a program. Write a program. Write a program in which declare and initialize, declare and initialize an integer array of size 5 and and using a function not use and use a function in which you will be passing that array, and use a function in which you will be passing that array and increment every element of array by 2, and increment every element of array by 2. For that, using the same logic, using this array to pointer, using the array to pointer logic, you will be doing this. Using this based on this logic, this discussed logic. Okay, you will be doing this program. So in next class, we'll start with these 2 programs given to you today. As of now, anybody any query? Anybody any query, dear? Anyone? Any other query? Anything you practice you were not able to understand what's going on? Puneet Kumar, yes, yes, okay. Am I clear? You will be doing those 2 questions which I have given you right away. You will be doing that program. Okay. There's one more. If you have time, if you don't have class, then we can discuss one more that way of passing array to a function. I think some of the students have class at 4. FEC class है? Okay. Mahesh is saying yes, we can have. It's just one, but students have FEC class, so that's a challenge. That's all right. That's just one 10-minute program. One 10-minute program. If we could have done that, this topic would have been completed.